Hello and welcome to Hangin' with Hussick. This one's about unit conversions, SI units, and the metric system. Okay, so using conversion factors and dealing properly with units is something that's ubiquitous in the physical sciences and physics and chemistry. So it's a type of stuff that's going to be useful, a useful skill and useful habits and routines that you're going to need as a chemistry and physics student for sure, and across the sciences really in general. So it's really a way to approach problems, and what you want to do is you want to be able to identify in a problem that needs some conversion, what's the target unit, like what's the unknown that you're after, what's the given unit, like what's something that we do know that we can start with, and what are the conversion factors? So what are factors that we're going to need to relate one unit to another? Okay, so in this problem below, if we read it together, we'll see it says gasoline in Seattle, Washington costs $4.45 US per gallon. Okay, so that's what that GAL means, per gallon. You will use 39.5 liters of gas driving around Seattle this weekend. If 1 liter is equal to 0.264 gallons, what is the cost of your gas for the weekend? So pause the video and see if you can figure out these three features up top here. What's the target? What's the unknown? What are we after? What's the given? What's the known value? And what are some conversion factors that we're going to need in this process? Okay, so hopefully you looked through and you see that our unknown, what we're actually after, is like the question that's being asked. So that's what's the cost of the gas, okay? So let's write that down, and let's make sure that right at the far right-hand side, we realize that what we're finally after is the cost, and in this case, it's going to be a cost in US dollars since we're driving around somewhere in the United States, okay? Then we're going to try and identify what's given, what's known. What do we actually know, okay? Well, we could say, well, we know the 4.45 US per gallon, but that's actually more in the line of a conversion factor. That's telling us a relationship between two things. So that's a conversion factor, how much it costs per gallon of gas. We also have this conversion factor, that 1 liter is the equivalent volume to 0.264 gallons. Okay, so 1 liter being the metric unit and gallon being the imperial unit used regularly in the United States. What we're given essentially then as our starting point that's specific to this case is that we are going to use 39.5 liters of gas. So we're going to start there actually. We're going to say, let's get down that we know we're using 39.5 liters of gas, okay? And so we have to somehow get our units from liters all the way over here to US dollars, and our final answer is going to be in US dollars, okay? So we know we have to convert away from liters into gallons, okay, for this part, and then we'll have to convert from gallons to dollars using this part, okay? So maybe you almost need to go backwards there and say, look, we're going to have, the only way we can get USD with what we've got is saying how much we're going to spend per gallon. That's $4.45 per 1 gallon. So that's a conversion factor we're going to use there. And then we can say, well, to get to that, we're going to have this gallon gone. So we're going to have to convert gallon to liter here, which will help cancel out the value of the units of liters when we multiply that factor. So we know that for every 1 liter, we're getting I can hardly fit it in here, but I'll write it anyway, 0.264 gallons, okay? So then the final thing to do here is just do the math, and you'll see that all of the units you want to cancel will cancel, right? We have gallons on top, gallons on the bottom, liters on the bottom, liters on the top. So we're going to be left with our target unit of US dollars like we want it to be. Then we just do the math, 39.5 times 0.264 times 4.45. And that gives us, beep, 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 punch it in a calculator, 46. So if you could fit it here, that was kind of my goal, $46.40 US. US dollars is how much that's going to cost. So $46.40 US dollars. That's the cost. Now maybe you might even have to convert that to Canadian dollars if you're a Canadian and interested in how much it's going to cost in Canadian, and that would be another conversion factor we could put on there. But just to show you and just to try and code things here in the end, again, we used two different conversion factors. There they are in blue. We had a given value, which was here in green, and we had a target value, which was the unit we had to get to in the end, there in yellow. Okay, so now we can take this from sort of an everyday colloquial example and try to apply it to more scientific contexts using metric units, which we use as standards in science. Okay, so I've imported this well-designed table here on the left. It actually did look nice at one point, and I don't know what happened, but anyhow, it's a table. And what it's got, very importantly for the metric system, is it's got in here the SI units. So I'll take a second and discuss what these SI units are. So in the metric system, these are the standard units for measuring different things. Okay, and SI stands for Système International. The metric system was designed in France, so the acronym is a French acronym. But what it basically means is that if you're measuring distance, for example, the standard unit of distance is the meter, okay? So that's a meter. If you're measuring time, the standard unit of time is the second. If you're measuring volume, as we often do in chemistry, the standard unit of volume is a liter. If you are measuring mass, the standard unit of mass is a gram. And there's some others as well, like there's Kelvin for temperature, there's the mole for amounts of things, etc., etc. There's various ones, okay? But these are the standard units. Now what this table is telling you is how you can put different prefixes, as you see in this column on the left, giga, mega, kilo, deca, etc., different prefixes, and you can express the standard metric unit in larger or smaller quantities, okay? And so we're going to use this table to do some conversions specifically within the metric system on some subsequent examples. Oh, hey, there's a mistake. I just noticed it when I was working on the next slide. That's not M, it should be Greek letter mu for micro. Okay, so here's a few examples I'll work through with you on these. Of course, it would be best for you to pause the video and give it a crack yourself, or if I do the first one, then you could pause and try the second and third yourself. Something like this. Work at your own pace, challenge yourself to actively participate, okay? So we're gonna firstly try to express 2.3 dm. Go over here to the list, that's decimeter, okay? 2.3 decimeters in micrometers. So to do this, I think I've established there's kind of like an easy way that involves more steps, but I think is a little bit simpler and robotic. And there's a more difficult way that involves fewer steps and is a bit of a shortcut. So I'll show you the easier way that involves more steps. And what it involves is interpreting what the chart is showing you here, okay? So what it means is that 1 decimeter, okay, is a 10 to the minus 1 of a meter, okay? So it's giving you a conversion factor in this chart, all right? It's telling you that for every 1 decimeter, it's 10 to the minus 1, or it's 0.1 of a meter, 1/10 of a meter. So we're going to start by just writing out what's given, just like before, 2.3 decimeters, and we're going to identify our target unit, which is the micrometer. Okay, so we're going to have to get this thing to micrometers in the end. But what I would suggest is doing it step by step, going back to the base unit of the meter. Okay, because that's how, in this column here on the right, that's how this is expressed. It's expressing it based on the base unit of, in this case, the meter, right? So 2.3 decimeters, let's convert that to meters. Okay, so we're going to multiply by whatever the conversion factor is, meter to decimeter. And we just established that for every 1 decimeter, give my pen back, 1 decimeter is 10 to the minus 1 meters. Okay, so here's our first conversion factor that we're going to use. Okay, now if you look at our unit analysis, the decimeters are canceling out, and we would have our units in meters. So now what we have to do is go from meters to the target unit of micrometers. So we're going to put that in next. So over here we go look at the list and we see micrometers. Oh, that's not the right symbol for the micrometer. I just now noticed. Didn't convert right from the file. It should be this Greek letter mu. So for every 1 micrometer, it's 10 to the minus 6 meters. All right, so we're going to put micrometers on top. For every 1 micrometer, it's 10 to the minus 6 meters, like that. Okay, if we do that math, we're going to see the unit of meter cancel out, and we're going to get our units in micrometers the way we want them to be. Okay, so now we do the processing there, and we're going to see it's basically 2.3 times 10 to the minus 1, okay, divided by 10 to the minus 6. So we're really subtracting the negative 6 according to our exponent laws, and that's going to equal 2.3 times 10 to the 5 micrometers. Okay, with the right symbol. Yeesh. Okay, let's try the next one. 7.1 megaseconds in micrometers. That doesn't make sense. Who wrote this question? Oh, I did. I'm sure it's meant to be microseconds. So if you tried that one paused, you were like, what? Never mind. Carry on. 7.1, we're going to start with what's given, megaseconds. And we're going to convert it to the base unit of seconds. So if you look at mega over here, capital M, you're going to see for every 1 megasecond, it's 10 to the 6 seconds. It's 1,000,000 seconds. So we're going to multiply that to get it to the base unit of seconds. 10 to the 6. Okay, is the conversion factor there. And then now that we're in the base unit of seconds, we're going to multiply by whatever the microsecond per second value is. Come on over here to micro, and you're going to see, once again, that for every 1 microsecond, there's 10 to the minus 6 seconds. That's what that means. And there we go. And there we go. So if we want to do the final math here, we're going to see that we should have 7.1 times 10 to the exponent 6. And then you're going to, according to exponent laws, you're going to subtract the minus on the bottom. So it's minus 6, getting a little bit tight here. But that basically equals 7.1 times 10 to the 12 microseconds. Now you should ask yourself logically, does this make sense? Would you expect that if you had 7.1 megaseconds and you express it in the much, much smaller unit of microseconds, would this number get humongous, like 7.1 times 10 to the 12? Of course it would. It would get huge, right? Okay, and then trying the last one, we're given 11.3 millimeters, and we want to convert it to our target unit of nanometers. All right, so let's first take it to the base unit of meter. So we're going to use the conversion factor meters to millimeters. Going over to milli, and you can see that for every 1 millimeter, it's 10 to the minus 3 of the base unit, which in this case is the meter. So 10 to the minus 3 meters is going there, and 1 right there. We're going to multiply that. Now we'll have our units in, oh, I forgot to do all the fancy canceling up here, which I find so satisfying. We're going to, now our units are in meters, we're going to convert them to the target unit of nanometers. So down at the bottom, nano is the smallest little unit, and we see that for every 1 nanometer, it's a 10 to the minus 9 of a meter. Teeny tiny. Meters cancel. Now we do the math, and we see we're going to have 11.3 times 10 to the minus 3 minus 9. And the units will be in nanometers. 11.3 times 10 to the negative 3 plus 9. That's 10 to the 6 nanometer. I hope this makes sense to you. And we'll look at some even more complex ones that are squared or cubed. Okay, so we've been working with one-dimensional unit conversions. What if there's multi-dimensional? What if it's like area, which has 2 dimensions, and we need the units to be squared, right? Square meters, or etc. What if it's a volume where we might want our units to be cubed, okay, like a cubic meter, etc., etc. How do we deal with this? Well, the name of the game in this case is basically you use the same conversion factors as we have over here on our table. It's just if you're squaring the unit, you're also squaring the conversion factor. And if you're cubing the unit, you are also cubing the conversion factor. So we'll look at a couple of examples that demonstrate that. So let's say, for example, we had 4 square meters, and we were tasked with determining how many square centimeters is that, okay? And on the cubic side, let's imagine we had 78 cubic meters, and we were being asked to convert that into a cubic megameter, okay? So whatever you do to the whatever the conversion factor is, you got to square it as well if it's a squared unit, and you have to cube it if it's a cubed unit. So we'll start with the first one. So we would say, all right, if we have 4 square meters, right, we have to come up with our conversion factor here. So we're going to start with the same idea, trying to get to centimeters. We're going to start with the idea that 1 centimeter is 10 to the minus 2 meters. So we're going to put our 10 to the minus 2 meters down here, and we're going to put our 1 centimeter up here, okay? But you'll notice that that's not going to cancel out the units. We have to square everything. So you square the entire conversion factor. And when you square the entire conversion factor, okay, remember your exponent rules. You're going to have the centimeter unit squared, and it's all squared together as if it's like in a bracket, although you don't see that written very often, but it's the c squared and the m squared. And then the number 1 squared, well, that's just also 1, okay? So far on top, if we translate this, we've got 1 square centimeter is generally how you see that written, okay? On the bottom, we are going to square the meter, so we're going to get this into meters squared. And then we are also going to square, very importantly, the exponent. So 10 to the minus 2, if I write it over here, squared is the same as saying 10 to the minus 2 times 10 to the minus 2. And you remember from your exponent laws, that's 10 to the minus 4, okay? So this is 10 to the minus 4 meters squared. Now that is our actual conversion factor that we're going to use, okay, when we solve this problem. So now we've got our square meters cancel with our square meters. We're left with square centimeters at the top. So we're going to have 4 times, okay, you want to put base 10. So what's the number 1 written in base 10? The number 1 written in base 10 is just 10 to the 0. So we'd have like 10 to the 0 minus what we've got down here. So minus 4. All right, and then the unit would be centimeters squared. In other words, at the end of the day, we have 4 times 10 to the 4 square centimeters as an answer for that conversion. Okay, hopefully you could follow that one. Now, at the end, I always would encourage you, think about this. Think about this. If you have a 4 square meter area, so a great big 4 meters square on the floor, do you expect that to turn out to be a large number of square centimeters when converted, or a small number? And the answer should be, it should be a very large number, and that's what we see here. We see, it's 40,000 square centimeters. So that makes a lot more sense. If the number got really small, we would know that can't be right? Okay, let's try it with cubed. Let's try it with cubic. So if we go down here to the cubic, again, we're going to write what's given, our usual methodology, right? What's given. We know we're headed towards megameters in the end. So we're going to have to convert megameter on top, meter on the bottom, and we're going to have to cube this, okay, because it's cubic. So what's the conversion? Go on over here, and you'll see, just luck, I already had an arrow there, but 1 megameter is 10 to the 6 meters. Okay, remember that unit of meters would be there. So 1 megameter, 10 to the 6 meters. Then we are going to cube each of those things. So that's just going to be 1. 1 times 1 times 1 is 1. Or in other words, like 10 to the 0 times 10 to the 0 times 10 to the 0 is still just 1, right? It's still just 10 to the 0. So we're going to have 1 megameter cubed on top. And then on the bottom, we're going to cube the meter, okay, which is going to help make that unit drop out completely. And we're also, very importantly, going to cube the 6. So 10 to the 6 times 10 to the 6 times 10 to the 6, 10 to the 18. All right, so we've got our conversion factor there now. Here we are. And meters cubed cancel. And we're going to be left with megameters cubed. All right, so in the end, it's going to be 78 times, we had 10 to the 0 on top, remember, because we had a 1. And then we've got 10 to the 18 on the bottom, so it's going to be subtract 18. So essentially, 78 times 10 to the negative 18 megameters. Now that is an incredibly small number. Does that make sense? Sorry, all this is cubed. I'm being a bit lazy. There we go. Does that make sense? Does it make sense we'd have such a small number in megameters? Well, sure, because we started with 78 cubic meters, so we had this volume of 78 cubic meters. A cubic megameter would be this humongous volume, so we would need a very small amount of those. So I hope this helps you with working with these. Practice makes perfect. Practice, practice, practice.